Welcome to Logic Bytes. In this video, we're exploring Section 1.1, Statistical Inference, the foundation of learning from data to answer real-world questions. Introduction. Typically, we begin with a subject matter question and some data X obtained to address the question we have. Both may be simple or complex. A few examples are: what proportion of products produced in a factory are faulty? Exig. A sample of products and whether they are faulty. How effective is this drug? For a patient with a given set of symptoms and characteristics. X. Symptoms and characteristics of patients previously given the drug, whether or not it was effective. The data may be obtained in a very controlled way through a designed experiment or from an existing source. Once the data is obtained, we need to look at it through exploratory analysis, which involved graphical and numerical summaries of the data, means, medians, box plots, histograms. Then the formal analysis, or inference, begins. This aims to provide the best answer to the question and quantify how confident we are in that answer. Understanding random variation and model choice. The subject matter question usually concerns the systems behind the data, not just the data itself. We must therefore acknowledge that the data are subject to random variation. This can be thought of in two ways. We could consider that if we drew another sample from the same population, we would get different data. Second, we could see the data as incomplete representation of the systems we are attempting to describe. In order to account for this random variation or uncertainty, we assume the data X derives from some distribution or model, f of x given theta. The choice of which distribution may be based on subject matter knowledge and/or the exploratory analysis. We then were to infer about the parameter and AC theta. Check, and potentially revise the choice of model F. Finally, we relate our finding about theta back to the subject matter question.